so today we're going to be talking about converses and inverses and contrapositives. And in that context, we're actually going to be applying them to the initial statement of P implies Q. And keep in mind that P and Q here are representing these propositions, basically statements that either have true or false values. And so keep in mind that the initial truth table for a P implies Q statement, right? When P is true, Q is true, and P is true, Q is false, P is false, Q is true, and lastly, P is false and Q is also false, right? And the initial truth table of it will look something along the lines of this. Alright, and so basically this is the logical kind of definition of an implication statement. So once again, this is a truth table right here. Now, when we want to consider the concepts of converses or inverses or contrapositives, why bother with them? Why try to manipulate this statement that we're given here that we know P implies Q? Well, one of the primary reasons is when you're trying to prove, for instance, that an algorithm works, or when you're trying to prove a property of a certain algorithm, or trying to prove some sort of mathematical statement, being able to manipulate it and take, for instance, the negation or the contrapositive or the inverse of the converse, depending on exactly what type of statement you're dealing with here, and knowing the patterns it creates, whether it's what's called logically equivalent, will allow you to determine whether or not you can use that negation, for instance, as a primary part of your proof. So what do I mean by that? What exactly am I referring to? Well, let's talk a little bit about logical equivalence here. Logical equivalence. Right, and so ideally, when one statement, let's do this lovely scribble right here, is logically equivalent to your second statement, this other scribble right here, then whatever true or false values that it has, right, will be identical on either end. Based on the same circumstances. And by circumstances, I am basically referring to, for instance, if P and Q here are like true, and then here are like false and true for whatever statement that you have, right? So under the same circumstances, the logical values of your given statements will be the same, essentially. Alright, so let's walk through the concepts of these really quickly of converse, inverse, and contrapositive before diving into them, before exploring them and determining whether or not they are logically equivalent to our initial statement. So ideally and simply put, when we're talking about, when we're talking about the converse of a statement, right? Converse of a statement. That would basically be taking your original P implies Q and literally flipping it around. By flipping it around, I mean taking this P and taking this Q right over here and putting them in the opposite spots. So we're going to be putting it as Q implies P, right? And that's your converse. Alright, so moving on from there, then your next kind of type would be your inverse statements. And these inverse statements are a bit like taking your initial statement, once again, P implies Q, and instead of flipping it in terms of order, right? Flip order. We are taking the negation of it. And so we're adding this not P. Not P implies not Q. You can actually also write it as not P implies not Q. And taking that, that's what's called the inverse. And lastly, last but not least, you have the lovely contrapositive. And contrapositives are kind of interesting because rather than flipping the order, rather than taking the negation, it's basically a combination of the two. So if you had P implies Q, the first thing you do is you take the negation. The first thing you do would either be you take the negation or you flip the order. You're doing both. Let's say you flip the order first, right? So let's flip the order. Right. So then it'll be Q. Q implies P. and then you take the negation of that. So it's not Q implies not P. And so these are the basic definitions of your converse, inverse, and contrapositive. So now let's consider whether or not these statements are logically equivalent to your original P implies Q. Right, so P, Q, and let's construct a fundamental truth table. P implies Q, right? And so this is what we established earlier, right? True, false, oops, true, 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 false, false, true, false, and false. And as we said, and as we established at the beginning of the video, the primary pattern that we're seeing here looks a bit like this. Alright, now let's extend this line by a little bit and let's take our first scenario. Let's take a look at our converse, right? And that, in this case, would be Q implies P. Alright, so naturally, as you can see here, when both your values are true, right? When both your values are true, well, in this case, it's also true. Similarly, when both of them are false, quite clearly, the entire implication statement is also true. And when it starts being different, when P is true or when P is false and Q is a different value, is when it gets a little bit tricky. So because, keep in mind, we flip the places of Q and P here. Actually, here, when Q is false and P is true, we are considering an instance of a true implication statement, right? Because, Q is not a necessary condition for P. Alright. So now let's consider whenever Q is true and P is false. Keep in mind, if this is true and this is false, this is a classic instance of a false implication statement, right? Alright, and so when you take a look at this truth table, and if you look a little bit closely, you'll realize that these two right here, these two places, are not equivalent. False does not equal true, and true does not equal false. And so as a result, your converse is not logically equivalent to your inverse. Alright, now let's consider a different case. Alright, so let's say we want to consider your inverse statement. And so the inverse statement, keep in mind, is where you have not P implies not Q. And really quickly, let's construct this truth table that we have, right? So not P implies not Q. Not P implies not Q, right? And if you remember, not P is false whenever P is true, and not Q is also false whenever Q is true, and similarly, it is the exact opposite whenever these two values are false. Now, going on from there, let's consider, so once again, if the two values are the same, we're still looking at true statements, and this is where it gets tricky. So, not P, then that would be taking, for instance, that would be taking not P would be false, implying a true value, right? Because right here, Q is false, and so we just flipped it. And so this actually here is still valid, right? It's true. And here, once again, if we want to consider, then crossing this out, what we're looking at here is a true implies false. And unfortunately, in terms of implication statements, that is also false. And so once again, you see there's a lack of logical equivalence right here under these two circumstances. And as a result, this is not considered, once again, inverses are not considered logically equivalent to your initial implication statement. Alright, so last but not least, we will be taking into consideration, and I apologize for this interesting table that we now have. Alright, last but not least, we'll be taking into consideration the contrapositive statement. Right? And as we established earlier, that is not Q. Not Q implies not P, and that's your contrapositive statement. So once again, as we established earlier, when the two values are true, or two values are both false, you regardless will always have a true. Now, once again, this is where it gets messy. So when your Q is false, right, that means that not Q is true. And similarly, when P is true, then not P is false. And true implies false here, and the implication statement is false. And taking that same pattern and taking a look at it, we end up having a false implies true, and that makes this here, this third circumstance, true. And if you notice here, in this case, your contrapositive is logically equivalent to your initial statement. So that means P implies Q is logically equivalent to not Q implies not P. And so as a result, your contrapositive, yay, is logically equivalent, right? Contrapositive, logically equivalent. And so this is important to keep in mind whenever you want to, once again, apply a proof, apply a certain statement, and be able to show that it works, that it's true, or that it's false. You can take the contrapositive, and because it's logically equivalent, you know that no matter what you are referring to, you can look at them and process them essentially the same light. So if you can disprove your contrapositive, you have disproved your initial statement. And if you can disprove your initial statement, you can also disprove or prove. It can also disprove your contrapositive, and similarly, if you prove your contrapositive, you can prove your initial statement. That was a little bit of a long spiel there. But essentially, that's why it's kind of useful and really important to recognize the instances of contrapositives and converse and inverse and the relationships they have to the initial statement. Alright, so that is all. Keep learning, stay curious, and remember, if you have any questions, please don't hesitate to check out the Q-munity website.